This video will give you a brief introduction to the statistical idea of inference. So, statistical inference. What is it all about? Well, the purpose is to provide information about an unknown population parameter. A mean or a population proportion are the ones that we're going to work with in this course. But it's impossible to ask every single person in the population, usually, about something. So to be able to figure out what the value of the parameter is, we're going to use statistical inference to try to estimate what that parameter is, or to try to say some things about claims about that parameter. So when we take samples, we don't do that so we can learn about the people that are in the sample or the individuals in the sample, even if they're not people. But we do that so that we can infer from the sample data about the population itself. So inference is taking information from sample data, statistics from the sample data, and saying something about parameters in the population. Different samples that we take will lead to different conclusions sometimes. And so we can't be certain that our conclusions are correct. We take a sample of 100 TCC students. We may be off a little bit when we ask them how many of them eat in the cafeteria on a regular basis. And so I want you to just think, I'm not going to talk about it explicitly now, but think back to the central limit theorem and how we took multiple samples, and start to try to put some of this together in your mind about how this all fits together so that we can get the best information about a population and be as certain as possible that we're on the right track. But we're going to look and actually put some kind of a value to how trustworthy our conclusions are. So the three kinds of inference we're going to look at. The first one is point estimation. And in point estimation, we just make an estimate of a single number. So we take a sample and we calculate its mean, or we calculate the population proportion, and we report it. There are examples of that all over the place. The average American eats this many pounds of sugar a year. The average sales price of a home in Tacoma is this. The average 5-year-old is this many inches tall. Well, certainly not every American eats that many pounds of sugar a year, and not every house costs that exact amount of money, and not every 5-year-old is exactly that high. But we're saying something about just what it averages out to. Same with the population proportion. We could talk about the proportion of people that watch the Super Bowl. Well, we're certainly not going to ask every single person in the whole world if they watch the Super Bowl. But by taking samples and inferring from those samples, we can calculate the proportion in our sample that watch the Super Bowl and say that that's what we think is the proportion of people that watch the Super Bowl. Now, if we want to refine this a little bit, we're going to use interval estimation, so that one single number gives you no wiggle room at all. But it's really helpful if we can give a range of numbers and then our confidence that the true parameter is in that range. So we want to maybe say with 95% confidence. That's pretty confident. We want to say with 95% confidence that the percentage of people, the population proportion for people who watch the Super Bowl was between 1% and another percent, X percent and Y percent. And we'll give it that range of numbers because it's much more likely to actually fall within a range than to be at a specific point. So that refines the information that we give, and we have more space to capture the true parameter within. And the last thing we do is hypothesis testing. And in hypothesis testing, we're going to make a claim about a population. Maybe we'll say that 48% of Americans watch the Super Bowl. And then we're going to actually look at the sample data after we make that claim and see if our sample data supports it. Now, we use things like this a lot in experimentation where a drug company wants to be able to say before they bring a drug to market that 20% of people lower their cholesterol, say 20 points or more from this drug. And then they'll take their sample that they've used for testing their drug and they'll see, does that hold water? Does that sample data support a claim like that? If there is, they'll go the next step towards bringing it to market. If there isn't support for that, then they might go back to the drawing board a little bit. So this is really helpful stuff in figuring out if what you brought to the experiment, the hypothesis you brought and tested in the experiment, is supported or not by the sample that you take. So those are the basics of statistical inference. We will get in depth into each of these and talk about how to do them, the mathematical calculations that are involved, the thought process that's involved, and how to draw conclusions from them.